Enzymes. Enzymes are the proteins act as biological catalysts. They play a vital role in the various metabolic activities in body. The enzymes show maximum activity between 35 degrees to 40 degrees Celsius. They are practically inactive at 0 degrees Celsius and beyond 65 degrees Celsius get denatured, although they are soluble in water and dilute alcohol, but concentrated alcohol precipitates them. The factors like pH of medium has direct effect on their action. Enzymatic activity is reduced by formaldehyde, free iodine, heavy metals and tannins. The properties of enzymes which make them exceptional catalysts are as under. 1. They catalyze only a specific range of reactions, and in many cases only one reaction is catalyzed by a given enzyme. Some of them have a low degree of specificity like pepsin, which hydrolyzes almost all soluble native proteins. Hence, specificity is one of the most important characters of enzymes. 2. As a group, they are exceptionally versatile catalysts. They effectively catalyze hydrolytic reactions, dehydrations, oxidation-reduction reactions, and group transfer reactions, polymerizations and free radical reactions. 3. They are exceedingly efficient under optimal conditions. Most of the enzymatic reactions proceed 8 to 10 times more rapidly than the corresponding enzymatic reactions. The enzymes are classified into following categories. 1. Hydrolases, catalyze hydrolytic reactions. 2. Transferases, catalyze transfer of chemical group from one molecule to another. 3. Oxidoreductases, catalyze the oxidation-reduction reactions. 4. Lyases, catalyze the addition of groups to double bonds or vice versa. 5. Isomerases, responsible for intramolecular rearrangements. 6. Synthetases, catalyze the condensation of two molecules coupled with the cleavage of pyrophosphate bond of ATP or similar triphosphate. Further, on the basis of site of action, enzymes can be grouped as under. A. Endoenzymes. Those which act only inside the cell are known as endoenzymes or intracellular enzymes. These involve in the synthesis of cell components, food reserves and bioenergetic, i.e., liberation of energy from foodstuffs. Since these processes are intracellular, enzymes involved are also intracellular. Examples are synthetases, isomerases, phosphorylases. B. Exoenzymes. The enzymes which are secreted outside the cell are known as exoenzymes or extracellular enzymes. These are normally digestive in their function. These hydrolyze very complex molecules into simpler compounds, proteoses, lipases, amylases acting on proteins, lipids or starch respectively. Many of the enzymes also possess non-protein chemical groups. An enzyme moiety comprises of a protein component, apoenzyme, and a prosthetic group representing non-protein component. The latter is also called as cofactor or coenzyme. Certain metals and vitamins are coenzymes. Fibers, sutures and dressings. The fibers are elongated thick-walled cells with pointed ends. Cells' walls consist of cellulose, may or may not be lignified. They are used as surgical dressings made up of artificial material. Fibers are obtained from plant, animal and mineral sources or from synthetic sources. Fibers obtained from various sources are classified as follows. A. Plant fibers: jute, flax, banana, cotton, hemp. B. Animal fibers: silk, wool. C. Mineral fibers: glass, asbestos. D. Synthetic fibers. 1. Fibers regenerated from carbohydrates material: artificial silk. 2. Fibers regenerated from protein: fibrolan. 3. Synthetic nylon. Surgical dressings. The word surgical dressing is used to include all the materials either used alone or in combination to cover the wound. The purpose of application of dressing is to protect the wound and favor its proper healing. A material which holds the dressing in desired position is known as bandage. Fibers are used for the preparation of surgical dressings. Surgical dressings are meant for the following functions. 1. To reduce or prevent infections. 2. To offer protection to healing wound. 3. To offer mechanical support to the tissues. Surgical dressings should comply the following requirements as mentioned in Pharmacopoeia. 1. They should be sterilized before use. 2. They should be stored in dry well-ventilated place at a temperature not exceeding 25 degrees Celsius. 3. They should be used with permitted antiseptics in prescribed concentrations. 4. They should not be dyed unless mentioned in the monograph. 5. Adhesive products should not be allowed to freeze. 6. There should not be any loose threads, fiber ends in dressings. Surgical dressings are classified as A. Fibers. A. Non-medicated fibers absorbent cotton, wool, rayon, silk etc. B. Medicated fibers boric acid wool, capsicum wool etc. B. Fabric. Absorbent lint, absorbent ribbon gauge boric acid lint, absorbent gauze etc. C. Bandages. A. Non-medicated bandages crepe bandage, calico bandage, cotton and rubber elastic bandage. B. Medicated bandages plaster of Paris bandage, zinc paste bandage, zine paste isethymol bandage. D. Rubber and oil impregnated materials. Belladonna self-adhesive plaster, zinc oxide self-adhesive plaster, etc. British Pharmacopoeia recognized the following types of surgical dressings. 1. Fibers and related materials, i.e., viscose, animal, wood cellulose wadding. etc. 2. Carded products, L. Absorbent cotton, viscose wadding, etc. 3. Non-extensible, non-adhesive woven products, i.e., absorbent muslin, domet bandage. 4. Non-extensible adhesive woven product, i.e., belladonna adhesive plaster, zinc oxide surgical adhesive tape. 5. Extensible non-adhesive products, i.e., cotton bandage, elastic web bandage, etc. 6. Extensible adhesive woven products, i.e., elastic adhesive bandage, extension plaster. 7. Non-woven products, L. Impermeable plastic surgical adhesive tape, permeable plastic surgical adhesive tape, etc. Sutures. These are the sterile threads, strings or strands specially prepared for use in surgery meant for sewing tissues together. Sutures must possess the following properties. 1. They must be sterile and should cause no irritation. 2. They should have finest possible gauge and adequate strength. 3. If absorbable, their time of absorption must be known. 4. They are intended for single use only. Sutures may be prepared from intestinal tissues and tendons of animals and birds, vegetable fibers, camel hair, human hair, synthetic threads or metallic wires. Depending upon their characteristic of absorption, i.e., digestion in the tissues of the body, sutures are known as absorbable or non-absorbable sutures. Various methods are used to sterilize sutures. A few of the important method or chemical sterilization or sterilization by irradiation, and sterilization by heat. Heat sterilization involves two processes and sutures are grouped into two categories depending upon heat resistance. A. Boilable, in anhydrous liquid, and B. Non-boilable. The sterilization should not affect the properties of sutures or the utility. In irradiation method, sterilization is carried out by electron particles or by gamma-HAV from cobalt-60. The recognized dose of gamma rays treatment is 2.5 MegaRad. Sutures may be of the following types. 1. Absorbable sutures. A. Sterile catgut, small intestine of sheep, ox and appendix of deer. B. Sterile reconstituted collagen suture. 2. Non-absorbable sutures. A. Sterile non-absorbable sutures, silk and cotton. B. Sterile polyamide sutures, nylon. C. Sterile polyamide sutures, nylon. D. Sterile polyester sutures, terylene. A. Sterile braided sutures. F. Sterile stainless and silver sutures. 3. Hemostatics. I. Oxidized cellulose. E. Absorbable gelatin sponge.